Good morning. We will be looking at some more logarithms today. Today we're going to do some operations, multiplication and division with logarithms. Let's first look at what that means, when we break it down. So if I have log base 2 of 8 plus log base 2 of 16, just to kind of recall what logarithms mean, this is an exponent. This is an exponent, okay? Because if you recall, this in exponential form would be 2 to the third is equal to 8. So this whole thing here is equivalent to the 3, but it's the exponent, and this is also an exponent here. So it's important to think about what it meant to multiply numbers with exponents before we do operations with logarithms. So if I had 2 to the third times 2 to the fourth, we know that would give us 2 to the seventh. So the exponents are being added, but that happens when we multiply the bases or the entire value. Okay, so when we're in fact in this case, what we're doing is we are multiplying the bases as so the 8 times the 16 would give us 128. Okay, so just as we're looking at operations with logarithms, the main point is to think of them as exponents. So when you add the exponents, you're actually multiplying the numbers. So logarithms are kind of exponents in reverse. So just think about that as we look at a few examples of using operations here. Okay, so if we have log base 8 of 9 plus log base 8 of 4, remember those are exponents being added together, which means we're actually multiplying the number. So it would be log base 8 of 9 times 4, okay, or log base 8 of 36. Okay, and it's important to remember you can't add exponents when bases are different. So this, in order to be able to use multiplication operations with logarithms, they have to have the same base. So if you notice in these two numbers, the base is 8 in both cases. Okay, and same thing with this one here. The base is 7, so we're able to multiply the 3 and the 2. So log base 7 of 3 times 2, or 6, is the solution to this this addition problem here. Okay. Okay. So and same thing when we're dealing with variables here. So in both of these cases, we multiplied, and so as we're adding the exponents, we're multiplying the 3 and the 2 here, and the 9 and the 8 here. Okay, so in this case, log base 5, we can multiply them since the bases are the same, and then 5 times z is simply 5z. Okay, let's just a couple examples of subtraction, or when we subtract exponents, keep in mind that we're dividing the values. So log base 6 of 14 minus log base 6 of 2, the bases are the same. So when we're subtracting exponents, what are we doing with the numbers? We are dividing them. So this would be 14 divided by 2, or log base 6 of 7. Okay, one more quick example. So again, we have the same basis here, log base 3. So the exponents are being subtracted because these represent the exponents. So what's happening with the values of the numbers? They're being divided. So this would be 24 divided by 3, which is equal to 8. So log base 3 of 8. Okay, just a couple more quick examples, and I'll let you get some practice in. Okay, so log base 40, we're given if log base b of 5 is equal to 0.5 and log base b of 8 is equal to 0.6, evaluate the expression. Okay, and then the expression is log base b of 40. And we know that log base b of 40 would be the same as log base b of what we're given up top of 5 plus the log base b of 8. Okay, so again, so I'm rewriting log base b of 40 as log base b of 5, which we know, and log base b of 8. So those are equivalent expressions. So that, in other words, that's the same as log base b of 40, of which we're looking for. Only now we know that this is equal to the 0.5, and this is equal to the 0.6. So when we add those, we get an answer of 0.5 plus 0.6, or 1.1. Okay, same thing with division here as well. Log base b of 5 is 1.5. Log base b of 3 is equal to 1, and we're supposed to evaluate log base b of 5 divided by 3. So log base b of 5 over 3 is the same as log base b of 5 minus log base b of 3. And since we're given both of those values up top here, we can simply replace that or substitute the 1.5 for the log base b of 5 minus log base b of 3 is going to be equal to this 1, so the solution would be 0.5. Okay, so go ahead and give those a try, and I'll be available to answer questions as you're working through. Okay, good luck.